Okay, today we will be talking about scientific notation. Now we use scientific notation in order to better represent numbers that are really, really, really large or really, really, really small. So numbers that are really large, for example, the distance in miles from planet Earth to the moon, and numbers that are really, really small, for example, are like the size of a cell or atoms. It's a really, really small number. Okay, so let's go ahead and get started with our notes. Scientific notation is used to write really large or big numbers or really small numbers. And it is done by using the power of 10. What do I mean by the power of 10? We have always a times 10 and then to an exponent, okay? So this is always going to be in scientific notation. Now, the numbers that you have to come up with is the number between 1 and 10, so basically one digit before the decimal, it cannot be 0, and the exponent, okay? So these are the two numbers that you have to come up with. You automatically always put times 10, that's your power of 10. Okay, so let's see how we write numbers in scientific notation. Standard notation, that just means how we regularly write the numbers, okay? So we are going to place the decimal point so that there is one non-zero digit, that's this one digit that cannot be 0, to the left of the decimal point. So again, just one number that's not 0 and then the decimal. That's how you come up with this number. Now let's come up with the exponent. You're going to count the number of decimal places that it has moved from the original number. So again, you're counting from the new to the original number. This will be the exponent. And now let's figure out whether our exponent is going to be positive or negative. If you have a very, very large number, your decimal is going to be moving to the right, so you have a positive exponent. Just like in the number line, the positives are on the right. And if you have a very, very small number, your decimal moves to the left, which makes it a negative exponent. So let's go ahead and go over some examples. I'm going to go ahead and flip this real quick, and we're going to write a couple of examples here. Let's say that you're starting with really small numbers. Now I know there's a comma there. Do not worry about the comma, okay? We are not using the comma for any purposes. It's just there. Now remember that our first step is to place the decimal, and I only want one digit that's not 0 in front of the decimal. So here we go. One digit that's not 0 in front of the decimal. So I'm just going to write 2.24. I don't need to write any of those zeros. You just write the numbers that are important that have an actual value, not the zeros. And then we know that it's times 10. And remember, now we have to count the number of decimals from new location to the old location, okay? So count decimals from new to original or old location. So I don't see an old location. So since it's a whole number, remember that the decimals go at the very end. Just like in language arts, the period goes at the end of the sentence. So we'll go to the end here. That was your original decimal. So I'm going to go from new to old. Let's see how many hops. 1, 2, 3, 4, 5. Since I moved to the right, it's going to be a positive 5. Okay? Remember that that exponent does not mean how many zeros you're adding or how many zeros you have. It means how many times the decimal moves, not the zeros. Okay, let's do another example. Okay, again, we ignore the commas. And we're going to figure out where our new decimal goes. Remember, I want one digit that's not 0 in front of the decimal. So if I put it here, that's 2 digits in front. I don't want that. I want only one digit. So here. So now I have 6.7 times 10. And remember that we're counting our decimal placement from the new to the old one. So from the new, and oh, remember, it doesn't have an original one, so it's your job to write it down. It goes at the end when it doesn't give it to you. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8. And it's positive because I went to the right. Okay, let's do another example. Okay, now this is an example of a really, really small number. And let's figure out where our new decimal is going to go. Remember, I want one digit that's not 0. So not here, not here. No, I still have zeros in front. Not here because I still have a 0 in front. I want one digit that's not 0 in front of it. So right here. 6.23 times 10. Now remember, you're counting from new to original. So 1, 2, 3, 4, 5, 6, 7, 8. And I move to the left, so that's going to be a -8. Okay, let's look at one last example. Okay. Now the first step again is to place the new decimal. And remember, I want one digit that it's not 0 in front of it. Still 0, 0, still 0, still 0. Oh, just 1. Here we go. So 5.124 times 10. And remember, you're counting from the new decimal to the old decimal. 1, 2, 3, 4, 5. So it's to the 5th power. Since I went to the left, it is a -5. And that's how you turn numbers from standard notation into scientific notation. Now let's go ahead and do it the other way. If I give you scientific notation, I want you to write it in standard. So they're going to give you the scientific notation, and you're going to have to give me the original number. Okay, so let's get the notes for that one. You're going to move the decimal to the right, this direction, for positive exponents of 10. So again, if you're moving to the right, you are going to have a positive exponent. The exponent tells you how many places to move. You're going to move the decimal point to the left for negative exponents of 10. Again, the exponent tells you how many places to move. Remember that the exponent tells you how much you're moving, not how many zeros you're adding. And then you write the number. So let's go ahead and do some examples for this. Let's say I give you 2.25 times 10 to the 3. Since I have a positive 3, that means I'm moving 3 spots to the right. So show me your hops, 1, 2, and 3. I have an extra hop there. That means I need to fill that in with a 0. So 2, 2, 5, and 1 0. There you go. So it's not put 3 zeros at the end. It's moved the decimal 3 times. If you have any spots left, then you write zeros for those. Let's go through another example. Okay, 2.15 times 10 to the second. I am moving 2 places to the right since it's positive. So you're going to take that exponent, you're going to move it 1, 2. I don't have any empty spots to fill in with zeros, so that's just 215. That's it. You do not write with zeros unless you have empty spots. Okay, let's do one last one with a positive exponent. Okay, now when I look at my exponent, it is a positive 6. That means I'm going to move 6 to the right. So 1, 2, 3, 4, 5, 6. So when I rewrite my number, and I have 1, 2, 3, 4 spots, that I can fill in with zeros. Now let's try numbers with a negative exponent. Okay, you're going to take that decimal. Since it's -4, that means I'm going to move to the left 4 times. 1, 2, 3, 4. And that's where your new decimal is. Now I have 1, 2, 3 spots that I can fill in with zeros. And then you write your number. Okay, let's do one last example with a negative decimal. Since you have a negative decimal, again, you're going to move to the left. So you're going to take that exponent and move it 2 times to the left. 1, 2. I only have 1 spot to fill in with zeros. So you just put the 1 0 down there. And that is how you go from scientific notation to standard notation.